was the area of the parallelogram?
25.
25? Do we agree? Okay. What was the area of this trapezoid?
30.
Kite? Triangle? 21? And this quadrilateral? 16. Do we agree on all the shapes? Are there any questions about any of them?
Do you have to break up the shape in order to find that?
What do you mean?
Like, oh, we could just use a formula?
There's a formula for all these shapes. Okay, the color copies obviously did not work. Okay, so I'm going to label the shape colors what they should be. Okay, this should be green. This should be blue, yellow, red, and this is green as well.
What about white?
Your background is white. Make sense?
Yeah.
So you have green, red, yellow, blue, another green, and then a white background. What is the area of your white shape?
234.
Nice, Myrna, you already did it? Okay, so this whole entire coordinate grid is 234 units squared. So all of this should be units squared. Okay, so now this is where the geometric probability comes in. Okay, your formula is area of your desired region over area of your total region. So use this definition to find the probability of landing on each color. Find it as a percent to the nearest tenth. So work with your table and find the percent to the nearest tenth. So for example, I'll do number 1 with you guys. The probability of landing on red. What is the area of my desired region? 30. And what is my total area? 234. So when you type that into your calculator, what do you get? 0.128 and change probably? So as a percent, what is that? Very good. So you're going to do that for the remaining 4 problems.
Is there 2 greens to be added in the other?
Correct. The nearest tenth. Right, what was the fraction for the green? 41 over 234 because you added the 2 green areas together, 25 and 16. As a decimal, what'd you get? 0.175, and as a decimal? Very good. Or as a percentage, sorry. Alright, blue, what's your fraction? Decimal? Point what? 0.0897. Okay, and then as a percentage, what'd you get? 9%. Okay, yellow. Which equals what? Very good. We've already done this one before. And your percentage? 12.8%. And last but not least, white. How did you figure out the numerator? You added all of your shapes together and did what? Subtracted it from 234, and what did you get as the numerator? 112 over equaled what? Okay, and your percentage? Very good. Okay, so that is all geometric probability is. Are there any questions on that? So the area of where you're going to make your mistake is probably calculating the areas of the shapes. Okay? Other than that, same thing that we were doing last class as far as setting up your desired over your total. Questions on the front? Alright, turn the page. Alright, so we have this table comparing theoretical and experimental probability. You just found the theoretical probability for this sample space. Fill in the values from above to the table below. Okay, so flip it over. Your red percentage was 12.8. Your green was, what was it, 17.5. Blue is 9. Yellow is 12.8. And white is 47.9. Okay. Now we will do an experiment and see how often we actually land in the colored space. Calculate the experimental probability from the data. Find it as a percent to the nearest tenth. Okay, so again, theoretical probability is going to be the area of like the facts. Okay, so if you did this experiment a million times, okay, the facts say that your number should be pretty close to 12.8%, 17.5%, 9%, etc. Okay, whereas experimental is if you're doing the trial by yourself. Okay, so it's an experiment. Okay, and we're going to look at something in a little bit of the an experiment done where your number of trials, the more trials you do, the closer you get to the theoretical probability. Okay, so first thing we're going to do is rip off like a little corner of your paper. So, and roll it up into a ball. Okay, then make a chart down here. Red, green, blue, yellow, white, maybe. I'm just kidding, probably not. You need to know the definitions and like the facts, but okay. Turn over your paper. You are going to drop this little ball of paper that you made, so hopefully you didn't make it very big. Okay? Drop it from, let's say, I don't know, is this like a foot? Okay, and you're going to, oh man, this could be bad. You're going to see where it lands. Okay, and out of 20 drops, make sure there are 20 good drops that actually land on the sheet. Okay, make a tally. You gotta make it really round. You want Play-Doh?
Yeah.
Okay, here, Devin. Grab a little piece of Play-Doh and roll it up. Katie.
And you get a Play-Doh.
Back table, this is gonna be dangerous. Here you go, Kinley, give that to.
Oh, wow.
So take a little piece of Play-Doh. Okay, you're dropping it 20 times. And then make your table. Make your table and then do your ratios. Okay, your bottom number is going to be 20. And then amount of times in land will go on top.
How many trials do we have?
Huh?
How many like trials?
20.
Make like a this.
Drop it in the center.
Make like a barrier. Yeah. Like it's weird. Green. It still bounces. If anything, it bounces. Make a barrier. I'm gonna do that.
Get 20 trials. Okay, you're gonna get 20, or obviously everybody at your table is gonna get 20. Okay, add your trials together. So that back table will have 80 total trials, and you're gonna add your data together. This table will have 100. This table will have 100. You guys will have 80, and you guys will have 120. You're gonna add your data together.
Okay, let's do this. There we go. I want to go twice. I didn't realize how oh no. Right, so we add
Do your 20, and then once you're done with your 20 and everybody's done with their 20, y'all are gonna add all your data together.
2. Cooperate. Oh, he's flattening it out. That's what I was just saying. I was like, what if he's flattening it? What if you just flatten it out? I don't like this game. I just wanted my math. Use a gold. That's such a good idea. I need to find out fish. If you flatten it out, it works. Put your formula sheet underneath it. Let me find it.
If you put your formula sheet underneath, Fernanda said it doesn't bounce as much.
That's a lot. Oh my God, she's right. It doesn't bounce at all. How does it do that?
Wow.
Mine bounced. You know what?
Yeah, mine bounced. I don't think it worked. Yeah, it bounced again.
Oh my God. I think some high drop. Yeah, I kind of just I got 5.
When you're finished, combine the data with your table.
Okay.
No.
I got.
How many you done?
Got 6 likes.
I haven't gotten I'm like yellow. There we go, now I understand. I'm not even halfway. Halfway done. Halfway. Oh my God.
I'm ready to shoot it.
Wow, you guys are so fast.
I'm about
Oh, what a sugar train.
Stop staring at me.
I'm almost done.
Okay, when you're finished, combine the data.
Okay, I'll
Oh yeah.
5 green, 2 blue, 3 yellow, and 2 white. 3 red, 5 blue, 5.
Everybody.
Oh my God. I have a 93 average. Straight
God, done. How many did you have? Wait, do you want to? Yeah, I'm starting with red, orange, red. Three.
Like a lot of it? Zero, no, Play-Doh. And the haircut? No, they got a finish. You're so mad.
Oh, me?
Raise your hand if you're still working.
Oh.
What's green? Just say on a white is 30.
When you're finished, answer number 1. Compare and contrast theoretical versus experimental. What did you notice and why do you think this occurred?
Wait, what's red? Red is 13%. And then blue and yellow is 6.
I have it. Oh, you do? Second row.
Yeah. No, this is it.
Oh,
Wait, you have two. Oh, no, this is the same.
When you're finished, answer that question.
Oh, yeah, here. 2, 4, 0, 5.
This one's yours, right?
3, 5, yeah.
Alright, are we finished?
Oh, no.
Alright. Fernanda, you guys' table. I'm gonna write your data down. I'm gonna write it small just so I can fit everybody's. What did you guys get as your red experimental? 20%. What about green? 18. Blue? 15. Yellow? 12. And white? 34. Oh, thanks. Okay, what did you guys say for number 1? Fernanda, y'all's table. We're going table to table.
We said, theoretical is strictly facts that they can, like, oppose and prove. And not everything is perfect.
Right.
So it's not always.
Awesome, because you have human error. Okay, and why do you think this happened? So it says, what did you notice and why do you think this occurred?
Because it's not gonna always be like the exact same theoretical.
What could have those other factors
height,
been? The height that you dropped,
if there was like
bouncing.
The size of your Play-Doh ball.
Correct, the size of the Play-Doh ball.
Surface.
The surface. So, very good. Alright, Carson, your guys' data.
Okay, red we have 13.7%.
Okay.
Green was 23.7%.
23 point what?
7%.
Okay.
Blue was 8.7%.
Okay.
Yellow was 20%.
And?
Okay, yours wasn't accurate at all. But yours you were.
And white?
35%.
Awesome.
That's
And do you guys have anything to add to what they said about number 1? No, so do you know what they said?
Yeah.
Which was?
Human errors cause differences like with surface and ball.
Awesome, and what's theoretical?
What?
What's theoretical probability?
Like the definition.
Yeah, like what is it?
It's like based on the facts what would be
Awesome. Alright, Devin, y'all's table, what is the first percentage? Red.
15%.
Green.
23.3%.
Blue.
15.
Yellow.
15.
And white. 32.5. And what do you guys have to say about all that?
We said that, like, based on the theoretical probability, like, even though it wasn't the same percentages, it was kind of, like, about the same, like, red and yellow were both the same, just like the theoretical, and then the white had the highest percentage, just like the theoretical.
Awesome. What should your percentages be adding up to?
100.
100. It should be pretty close to 100. Alright, so I'm running out of room to write data, but I still want to hear, like, feedback from you guys. What did y'all find back there?
For our red, we got, our red and green, we got same, 16.8%.
Okay.
And then our, yeah, 0.3%. And then, for our blue, we got 10%, and for our yellow, we got 17.5%, and our white was 40%.
Awesome. Do y'all have anything to add to number 1? No, same things? Okay. Emma, y'all's table, what'd you guys get, or what'd you find?
Red was 16.
Thanks, Emma.
I continue.
Yeah, go ahead.
Green was 21%. Blue was 9%. Yellow was 21%. And white was 33%.
Very nice. What about number 1?
People were just said what we were.
What did you have on your paper?
Like theoretical probabilities, like in a perfect world, and then experimental is actual raw data.
Very good. Good job, Mineral. Alright, any questions over the little activity that we did? Obviously everybody's data was going to be different, but I think we all had white for sure taking a large chunk of our percentage. Okay, I want to show you guys this little illustration thing. Okay, it's this adjustable spinner. Okay, and they have all these colors. So if I did 10 spins, okay, I'm going to spin, I'm going to skip to the end. Theoretically, they should all be 16.7% because they're even. Okay, well, with 10 spins, we see that data is, those two numbers are very different. Okay, now let's go to 20 spins. Okay, what do you notice about the data?
No, it's not the same. They all, I can't really, some of them changed, like the blue and yellow changed.
Some of them changed. Okay, but all in all, what do you notice about as far as the difference? It's getting closer, right? Okay, so now let's go 30. Now let's skip to 50. Okay, what do we notice now?
It changed again.
It's still changing. Okay. Okay, Mirna's gonna do 100. Now what?
We're getting way closer.
We're getting way closer. Now we'll go 1,000.
Who has the time?
This application.
Oh.
What do we notice?
They're really
They're really close. Let's go 1,500. Aww. 1,000 is our max. Okay, but what did you guys notice as the amount of experimental events went up? The closer that you got to your, what? Very good. So, in conclusion, everybody write this on your paper. The more trials you complete with experiments, the closer it will get to the theoretical. Okay, so that's really important. That's the main idea I want you to get away from comparing theoretical and experimental probability. That is huge, okay? So just know that the more, I can't spell, the more trials you do with your experiments, the closer it should be getting to the theoretical probability. Any questions? Alright, I'm going to give you 30 minutes to work on your homework. And then we'll take the skills check the last 20 minutes of class. Okay, so skills check is over geometric probability and experimental and theoretical.